So for number 39, we want to see if the sequence here converges. And now a sequence an converges if an tends to a specific limit as n approaches infinity. So what we're going to do here is we're going to take the limit of the sequence and see as n approaches infinity and see if we get a defined number. So we're going to go limit as n approaches infinity of en plus e to the negative n over e to the 2n minus 1. Okay. And actually, I'm just going to express this, just put this n here on the denominator so that we can understand this behavior a little better. So that is of e to the n plus 1 over e to the n divided by e to the 2n minus 1. Okay, so if we just evaluate this limit as it is, what we're going to do, what's going to happen is we're going to have the first one, e to the n, that's going to give us infinity over infinity. So that's not very useful. And so what we're going to do here is we are going to divide everything by e to the 2n, because that's the highest exponent. And if we divide it out, we're at least going to get a defined number somewhere, not just infinity over infinity. So let's divide 1 over e to the 2n on top and 1 over e to the 2n on the bottom. So if we multiply and divide by the same thing, we aren't changing the meaning, right? So this is equal to the limit as n approaches infinity. And now if we divide this, this is going to be 1 over e to the n, because I went e to the n divided by e to the 2n. So that gives us e to the n on the bottom. And then plus 1 over, and now we're going to have e to the 3n. And then over, let's see, we're going to have here e to the n, 2n divided by e to the 2n, that's just 1, minus 1 over e to the 2n. Okay, so I've divided everything out, and now let's take this limit. So over here, we're going to have 1 over an infinitely large number, right? And whenever I have 1 divided by infinity, that in practice gives me 0, because anything that I divide by something that is infinitely large, that's going to be so tiny, it's practically 0. So when we take this limit, we're going to have 1 divided by infinity, so that's 0, plus this is still 1 divided by infinity, so still 0, over, that's going to be 1 minus, that is going to be 1 divided by infinity, so once more 0. Therefore, this is going to be equal to 0 over 1, and that is equal to 0. And so we have shown here that we do have a defined limit, right? This sequence here tends to 0, so we can definitely say that it converges. We're going to say an tends to 0 as n tends to infinity, so an converges.